So let us discuss today about cams. Right, this may be the last topic for this theory of machines. So cam is basically used for having intermittent motion. Right, right. And cam is actually forming a higher pair. If you remember, we have discussed during kinematic pair, and this cam is having main application in some of the areas like this is inlet and outlet valve opening mechanism in IC engine, right? Inlet and outlet valve operating mechanism in IC engine, right? So here, as you can see, this push rod is basically considered as a follower. Right? This push rod is considered as a follower, and this is cam shaft on which this cam is mounted. This is known as cam, right? So this cam is going to provide required motion to the push rod so that this valve will open and close according to the requirement. You must have studied valve timing diagram also in your IC engine, right? Valve timing diagram. So basically from that valve timing diagram you will come to know about what is the duration of rotation, right, for which this valve needs to remains open, and for which duration it needs to be remain closed. So based on that angle in your valve timing diagram, you will design a cam profile, right? So from valve timing diagram you can design a cam profile, right? And one second, someone is there. So yes, so this is how you are having some of the application of this cam and follower. So mainly three components are there in this mechanism, right? One is the cam, other is follower, and third is the frame holding it, right? So this is how you are having the main three components of cam and follower mechanism. So if we see how there are different types of cams, then there are various ways of classifying this cam. So as you can see here, so based on the shape of the cam, it can be classified. Based on the follower movement, it can be classified, and based on the manner of constraint of the follower, it can be classified. So here, if we go for the first one based on shape, then it can be this flat or wedge shape follower, sorry, wedge shaped cam, right? We are discussing the types of cams. So here you can see it is wedge shaped cam in both the figures A and B you are having, right? And here it is this flat type of cam is there. So here remember this follower also. In this follower you are having this very sharp edge, so it is known as knife edge follower, right? And here in the follower you are having this roller, so this kind of follower is known as roller follower, right? So this is how you are having this particular different types of cams. And as you can see, this is force closed pair. If you remember it or not, I don't know, but this particular cam and follower is a force closed pair. So you need to provide some extra force in order to maintain the contact between cam and follower, right? So it is a force closed pair. And so that you can see here they have provided this spring force in order to maintain the contact between cam and follower. Here also spring force is provided. Here gravity is used actually, right? And here what they are using is they are making some positive kind of what we can say contact between cam and follower, so there is no need of spring, right? So this is how there is a slot in which this roller is moving. So and according to that follower motion we will get. So this is how you are having the various types of cams, right, based on this shape of cam. So if you go for other types, then based on shape only you can have this radial or disc type of cam that you can see as here. So it is going to have rotation, right? So that is why it is known as radial, right? So this is the radial kind of cam, which is going to have rotation about a particular axis, right? Apart from this, based on shape, it can also be a spiral type of cam, as you can see. So there are various ways of providing different shapes to the cam, and based on that particular shape it can be classified. Similarly, here you are having that cylindrical kind of cam, and here it is conjugate cam. So there are various types of cams based on the shape. So in globoidal cam you can have concave and convex shape of the cam, as you can see. And finally this is actually that globoidal, and this is the spherical. So in spherical, as you can see, the follower motion is perpendicular to the axis of the cam on which it is rotating. So in spherical cam you can get this motion perpendicular to the axis of rotation. Here also you can see this spring is provided in order to maintain the contact, right? So this is how you are having various types of cams based on its shape, right? Now the next is this based on the what we can say follower motion, I guess, right? If I am not wrong, you can see the second classification is based on the follower movement, right? So based on the follower movement, this is the different types, right? So if you can see here, so this is this RRR, let us note it down, that RRR, that is rise return rise, right? So here you are having rise of follower, and during this particular angle it is having return of the follower, and it will continue that rise return rise, right? After that this DRRD is there, so that is that dwell, rise, dwell and return, right? Dwell means your follower will not have any motion, right? So during this dwell time follower is steady, that is known as the dwell time. So dwell, rise, dwell and return. So this is how you are having this dwell, rise and dwell. It will again follow the same cycle. And finally this DRD, right? So again this is dwell means follower will be steady during that particular rotation of the cam. So this dwell, rise, return and dwell, rise, return, again it will continue. It may happen that after this dwell, rise, del, there will be a fall instead of this again dwell. There may be a sudden fall also. So that is the variation of this last one only, dwell, rise, dwell. So basically what this I mean rise and dwell is, if you plot any let us say angle of rotation, right, and your follower motion if it is here. So see, rise means what? It is going to rise up to a particular height, right? This may be the follower displacement, right? This may be the follower displacement. So during a particular angle of rotation, right, it is going to rise. So this may be the theta outstroke. And then dwell means the follower is not going to have any motion, so the follower will remain steady during that particular motion, during that particular rotation of this cam, and again it can return, right? So this may be the return of follower. So again, as you can see, displacement graph will go down because of its return. So this is how, this maybe you can consider as return stroke. So outward stroke and return stroke you can consider. So this is how you are having this what you can say, follower motion. So actually if I plot it on this particular graph, sorry, this particular schematic, then so what is going to happen during this rise is this cam can have this circular motion. So during that circular motion your follower can go up, right? Follower's displacement will be from here to here, right? When your this cam is here, it may take this shape, right? So your knife edge follower may be here only, right? So there will be a rise, and for certain period of time or certain angle of rotation, let us say for this one or whatever, it may be almost flat. So during this particular rotation it will remain steady, that is known as dual period, and then again there will be a return because this particular rotation will come. So what will happen is again it will come back to its original position, right, like this. Again it may return, right? So this is how this rise and this dwell, it means it will remain here only for this same height, right? So this may be dwell and this may be again return because it is going back, right? So this is how you can have the follower motion in your cam and follower. And finally one more way of classifying it is constraint of the follower. So constraint of the follower is as it is mentioned, it may be preloaded, it may be positive drive and gravity. So as we already discussed, preloaded means it may be provided already any spring force or something like that in order to maintain that particular contact. Positive drive means, as we have seen, that slotted bar was means slotted space was provided to the roller follower, so that there is no need of providing any spring force. And gravity operated also we have seen. So this is how you can have different types of cams. Similarly, you can also have different types of followers, and that can also be classified according to its shape, movement, and the location, right, of the line of movement. So based on shape also you can have followers as knife edge follower, roller follower, right, then flat disc, right, and spherical as it is mentioned here in the figure. So flat dish and spherical are also known as the mushroom type follower, right, as it is mentioned here, right? So this is how you can have the knife edge and roller follower. We've already seen how it is, right? So this is how you can have types of followers. Now based on motion or movement of the follower, it can be reciprocating or oscillating. So follower may reciprocate or oscillate according to the type of cam you are using to give motion to that follower. And finally you are having that location of line of movement. So it may be radial or offset. So if the line of axis of this follower is going to pass through this particular this axis of cam as it is here, then it is a radial follower, and if it is not going to pass through and it will be a little bit offset, then it is going to be considered as offset follower. So this is how you are having various types of cams and followers, right? So before going to this different types of motion of follower, first we will go through some of the important terms in this cam and follower, right? So here, as you can see, there are some of the basic things you must have idea before going to the discussion of this follower travel or various types of follower motion. So here if you see one by one, then let us say base circle, right? So base circle is this, as you can see in the figure. So what is base circle? So basically base circle is the smallest circle which is tangent to the cam profile, right? As you can see, this is cam profile, right? If you can see, this is cam profile, right, as it is mentioned here in the given figure. This is cam profile. So base circle is the smallest circle which is tangent to this particular cam profile, right? So as you can see, a base circle is the smallest circle which is tangent to the cam profile, right? So after this base circle, the next important thing is trace point, right? So what is trace point? So trace point is basically a particular point on the follower which you are going to trace throughout the rotation of cam, right? So in case of knife edge follower, it may be the tip of the knife edge. If you are going to take the knife edge follower, then this tip of the knife edge follower is going to consider as trace point in that case, right? While if you go for the roller follower, then center of the roller is considered as a trace point, as it is mentioned here. So this is how you are having trace point, right? Then if we go for pitch curve, right? So pitch curve is nothing but whatever the path taken by the trace point during the revolution of the cam, that is known as pitch curve, right? So once you know the trace point, then it is very easy to have idea about the pitch curve, because pitch curve is the whatever path traced by the trace point, right? So this is how you are having your pitch curve in case of this cam. So after pitch curve, if you see, there is pressure angle, right? So pressure angle is basically whatever at a particular point on your this pitch curve, if you take normal to that pitch curve, right? So pressure angle is the angle, right, between normal to the pitch curve and the direction of follower, direction of the follower, right? So here this is the direction of follower and this is the normal to the pitch curve. So here pressure angle is mentioned, right? So now once you know the idea, or once you have idea about the pressure angle, you can define the pitch point, because pitch point is the point at which pressure angle is maximum, right? So now that is how you can define the pressure angle and pitch point, right? So once you have idea about pitch point, then you can define pitch circle. So pitch circle is nothing but the circle which is passing through pitch point and which is concentric to the base circle, right? As you can see here, this pitch circle, right, which is concentric to this base circle and passing through the pitch point, right? So this is how you can have your pitch circle. And finally the prime circle. So prime circle is nothing but smallest tangent to the our pitch curve, right? As previously we have defined the base circle, which is the smallest tangent to the cam profile. Here this prime circle is smallest tangent to the pitch curve, right? So if you want to see, so where is pitch curve? This may be your pitch curve, right? This is your pitch curve, right? So what is this prime circle? That is the smallest tangent to the smallest tangent circle to the pitch curve, right? So this is how you are having this different important terminologies in your this cam and follower, right? So Once you have idea about all this, then we can go further for kinematic and physical
सर
derivative.
सर एक बार प्राइम सर्कल के बारे में दोबारा बता दीजिए।
Sorry,
सर प्लीज रिपीट अबाउट प्राइम सर्कल सर एक बार।
prime circle. So prime circle is, let me again show you what is prime circle. So as you can see, prime circle is this one, right? Let me rub other things, right? So let us focus on prime circle, right? This is prime circle. So basically this particular circle is your prime circle, right? So this circle is prime circle. So now how can you define prime circle? This prime circle is the smallest circle which is tangent to the pitch curve. This is your pitch curve, right? So if you again see the pitch curve, right, then this pitch curve is this one, right? So this
ओके
is
सर
how
ओके
you
सर।
can have your prime circle and pitch curve. Okay.
So how
यस अंडरस्टूड।
Okay, thank you. Yeah. Okay, so now let us move forward. So here this kinematic and physical derivative. So as you know, these are different derivatives for defining geometry and motion of the follower. So basically kinematic derivatives are going to define the geometry, while this physical derivatives are going to define the motion of the follower. Right. Now actually this kinematic derivatives are with respect to theta, right, while this physical derivatives will be with respect to time, right. So by having this primary idea about kinematic and physical derivatives, if we first see the kinematic derivatives, then let us say if we are defining the follower motion or follower displacement with s is equal to s theta, then what is the first derivative of this displacement? That will be ds by d theta. So basically this ds by d theta is going to provide the slope or the steepness of the cam profile. Steepness, right, of cam profile. Now if you go for the second derivative, right, this is s theta, if you go for the second derivative, then it will be d square s upon d theta square, right. So it is going to represent the radius of the curvature at a particular point in your cam profile, right. And finally one more derivative is there in order to maintain the smooth operation. This also needs to be taken care, that is d cube s upon d theta cube, right. It also needs to be controlled, right. So once you have this idea about this kinematic derivative, similarly we can also go for the physical derivatives, right. So in that case as our s is we have written as a function of this theta, theta can be mentioned as a function of time. Now if you go for first derivative of this s with respect to time, then ds by dt can be mentioned as ds by d theta into d theta by dt. So that is nothing but omega ds by d theta, as we all know, and it is going to provide the velocity of the follower. It is going to provide the velocity of the follower. Similarly, if you go for the second derivative, d square s upon dt square, then it will be d square s upon d theta square, d square theta upon dt square. So it will be omega square d square s upon d theta square. It is nothing but acceleration of the follower, right? So this is how you are having this second derivative, and here also you can go for the third derivative, that is d cube s upon d t cube, that is d cube s upon d theta cube, and then d cube theta upon dt cube. So basically it is omega cube d cube s upon d theta cube, and it is known as jerk, right? So this is how you have different derivatives in case of cam and follower, right?
Sir, what is the abbreviation S used for?
S is for displacement,
Okay.
right? S is there for displacement of the follower, displacement of the follower, right? So this is how you can have this different derivatives. Now if we go for the what we can say different types of follower motion, right? Let us see how we can have this motion of follower, but before that one simple thing is there, undercutting. So undercutting means if you have this what we can say that radius of your roller, right, which is less than the radius of curvature, then you may have this undercutting, right? Why? Because as you know, this pitch curve is the tracing of that point or particular what we can say trace point, right? And here you are having this cam curve. So in order to avoid undercutting, right, in order to avoid undercutting, the radius of follower must be greater than the radius of curvature of your cam profile, right? Or you can say your pitch curve, right, because it is almost same, right? So this is how you can avoid undercutting in case of cam and follower. Now if we go for this motion of the followers, in that the very first is this SHM, simple harmonic motion. So what is going to happen is actually in what I can say in practice you have to design the cam profile, right? So what you need to do is you have to take all this data, right, of your motion of the follower. So basically if it is provided that this follower is moving for outward or outstroke, one second. So if it is provided that, let us say, follower is moving outward with a simple harmonic motion during the what we can say 180 degree, and then it is having dual force of a particular degree of rotation, and then again it is coming back with this simple harmonic motion or whatever. There are different types of motion we will see. So based on this data you have to plot a cam profile. So in gate actually this graphical method and all the things are not there, so we are not going to focus on how you can draw a cam profile, but we will go for the analysis, or we will go for this analytic what we can say, we will go for this different different what we can say, this displacement, acceleration and velocity of this particular follower, right? So otherwise you can also go for drawing the cam profile, right? That is a different thing, but we are now going to focus on how our that follower is moving and how we can have the displacement of the follower. So in case of this SHM, simple harmonic motion, your S can be represented by h by 2 h by 2 minus h by 2 cos beta. So from where it has come? It has come from this what you can say, this figure only. So here in this figure, what is done is, whatever the follower travel is given, suppose 40 mm rise is given, then what you are going to do is you are going to take 40 mm as the diameter of this half circle, and then you are going to divide the whatever angle given in the equal number, or let us say 6 numbers. So for if it is going outwards during 120 degree of rotation of the cam, then you will equally divide that 120 degree, and then you will divide that particular distance also. So what is going to happen is, in this triangle, let us say this particular triangle, right? In this triangle, if you see, this is the radius, and as we have discussed, this is considered as h by 2, because the total you have taken as h, your full follower travel during the outward stroke is taken as the diameter, so this radius will be the half of it. So h by 2 is this distance. Here you are having this angle beta, right? So this particular distance is nothing but h by 2 cos beta, as it is mentioned here. So at a particular instant, right, whatever will be the distance traveled by follower, that is h by 2 minus h by 2 cos beta, right? Because this will be the distance traveled by the follower, and this distance will be this h by 2 full minus this h by 2 cos beta, right? So this distance will be this full, right? And you need to subtract this particular distance from this full distance. So that is how you are getting this h by 2 minus h by 2 cos beta, right? So once you are done with this, then what you can do is, and one more thing you can do is, beta can also be normalized as pi theta by phi, where pi is the full angle, right? As we are considering that pi in case of this simple harmonic motion, so this pi will be the full rotation of that particular point, right? Here theta and phi is what? Theta is a particular instant, right? And phi is the total cam rotation during outward stroke, right? So this is how you will be able to calculate the angle beta. At different point of time you will find different beta, right? So this beta can also be represented as pi theta by phi. So here if you go and check, see, you can check this, because suppose if you are taking or considering point 3, so while reaching point 3, the distance traveled or covered by a particular point on follower will be 90 degree. Theta will be 90 degree when it will reach point 3, and phi is the total, right? So let us say total is 180 degree. So what will be beta at that point? So beta at that point will be pi by 2, right? Because here you can see, right, here you can see this beta is equal to pi, theta is 90, phi is 180, right? So this is how you are having this beta is equal to pi by 2 at point 3, right? So this is how you can calculate this beta. Now once you have s is h by 2 1 minus cos beta. Once you have h with you, what you can do is you can calculate that v, which is equal to ds by dt, right? So it will be d by dt, right, h by 2 1 minus cos, then this beta is pi theta by phi, right? So, and as we all know, theta is omega t. So if you put all this value, right, then h by 2 1 minus cos pi omega t by phi. So if you are going to go for the derivation of this, what you are going to get is h by 2 1 will be 0, derivation of 1 will be 0 because it is a constant. Then cos pi omega t upon phi will have its derivation as pi omega upon 5, and minus sine pi omega t, so minus minus will be plus, then pi omega t by phi. So now from this you can check at theta is equal to pi by 2, what is going to happen? V will be maximum. So at theta is equal to 5 by 2, here omega t is theta. If you put theta is equal to 5 by 2, you will be have sine by 2, and that is 1. So that is why this h max will be h by 2 pi omega by 5, right? So this is how you are having the maximum velocity in case of this simple harmonic motion. If you go for acceleration, that is this dv by dt, so that will be this h by 2 pi omega by 5 square, right, and cos pi omega t by 5, right? And here again at theta is equal to 0, you will have a maximum, right? So that is h by 2 pi omega by 5 square. So this is how you are having the maximum velocity and acceleration during this simple harmonic motion, right? So once you are done with this simple harmonic motion, next can be constant acceleration. So here again this particular graph is going to help you when you are going to plot the cam profile. So how to take this points or different how this follower is moving according to the rotation of your cam, that is mentioned from this particular figure. So this is how you are having that constant acceleration in case of your follower is having constant acceleration and deceleration. Actually it will have constant acceleration during the half of the follower travel and constant deceleration during the remaining half, right? So now again if we go here for the equation of this displacement, then if we write for s is equal to ut plus 1/2 at square, right, in which u will be 0 because at start this velocity is 0. So what you will have is s is equal to 1/2 ut square, that will be your equation. So from 1/2 at square, right? So from this you can have a is equal to 2s upon t square. Now s is h by 2 because as we have discussed, during the half of the follower travel it will be constant acceleration and during remaining half it will be constant deceleration. So s will be h by 2 and the time will also be theta upon omega, where theta is theta by 2 or phi by 2, and so you will have this s and t value with you. So if you are going to put this in this equation, then what you will get is 2 into h by 2 upon t square is 5 by 2 omega square. So this is how you will get your acceleration is 4h omega square upon phi square. So once you have this particular acceleration with you, you can also find that velocity from this ds by dt. And as you know, s is equal to 1/2 at square, ds by dt is 1/2 into 2at. So your v will be equal to at. You are having value of a and t both, right? T is theta by omega. So if you put value of a and t both, then it will be 4h omega square upon phi square into t is nothing but theta by omega. 1 second. Right, so if you yes, if you write this 4h omega square upon phi square into theta by omega, so you can further
Sir,
simplify
T
it. Yeah.
is theta by 2 omega, no?
uh, yeah, but in general, if we write, we are not writing in terms of any outward stroke angle or inward stroke angle. In general, we have written that theta is phi by 2 in our case, but for now what we have written is from that simple relation, as theta is equal to omega t, we know, right? This is general relation.
Yes, yes,
Okay,
yes. Got
okay,
it.
so that is why it is theta upon omega. So if you further further simplify, then it is 4h omega upon phi square into theta. Now what is going to happen is, at theta is equal to phi by 2, you will have maximum velocity. So this is your velocity, right? So at theta is equal to phi by 2, you will have this v max, that is 4h omega upon phi square into phi by 2. So this is how you are going to get this 2h omega upon phi. So this is v max in case of this constant acceleration and retardation process, follower motion, right? So this is how you are having this velocity and acceleration in case of this constant acceleration, right? Now again, if we go for the next type of follower motion, that may be this constant velocity. So in constant velocity, as we know, it is going to linearly vary, right, according to this theta. So this is simple graph in case of this constant velocity. Here actually this is ideal and real value, or real ideal and real plot for this follower motion is given. Here actually these are all what you can say instantaneous increment and decrement are given, right, as you can see, but in practice it will be gradual, right? So this is how this ideal and real plots for this displacement, velocity and acceleration and jerks are given in case of constant velocity of the motion. Constant velocity, whenever follower is going to travel with constant velocity, how it is going to what we can say behave, and how we can plot it, that is mentioned, right? Now in case of this constant velocity, your this displacement can be directly written as h theta upon phi, right? And here also again you can put the different values as we have used earlier, like theta is equal to omega t. So if you are going to put those values, then your s will be h into omega t by phi. And from displacement, if you want to get velocity, then it will be ds by dt. So ds by dt, if you are going to write, then it will be h omega upon phi. So actually it is coming constant, right? It is not varying with theta, as previously we have found in case of other two types of motion, SHM and constant acceleration, right? Here it is constant, right? So that is why it is this constant velocity of your follower, right? And as velocity is constant, we know that acceleration will be 0, because acceleration is dv by dt, right? So this is how you are having this equations, or you can say displacement, velocity and acceleration during constant velocity of follower. And the last one is this cycloidal motion. So in case of cycloidal motion, here again these are the values, or we can say this particular plot is again going to be useful when you are going to plot cam profile, because during the different angle of rotation of cam, you will have this different motion travel by your follower at different point, right? So in previous examples also, here is the cam rotation angle, right? This is the cam rotation angle, right? And at different cam angle rotation, these are all the follower travel, right? These are all the follower travel, right? So here in case of cycloidal motion, what you are going to have is you know cycloid, right? You are having a particular roller which is rolling on a particular straight path without sleeping. Then it is going to have a cycloid formation, right, by different point or by a particular point on that particular roller. So here what you are going to do is, whatever follower travel is there, h is our follower travel, you are going to consider it as what we can say, this particular follower travel is nothing but the periphery of that roller which is going to traversing that cycloid. So h is equal to 2 pi r. So from this h is equal to 2 pi r, you are going to first draw this radius h upon 2 pi here, right? And then you are going to start plotting the different distance traveled by follower during the rotation of cam, right? So this is how you are having this cycloidal motion. In case of this cycloidal motion, mathematically this displacement is given by h upon pi, this pi theta by phi minus 1 by 2 sine 2 pi theta by phi. So again, once you have this, you can calculate the velocity and acceleration, right? So if you write the velocity, right, then velocity is ds by dt. So ds by dt means it is ds by d theta into d theta by dt. So here ds by d theta is h upon phi, because for the first term pi will cancel out and d theta by d theta will be 1. So h upon phi, right, minus h upon 2 pi, the sine 2 pi theta upon phi will be 2 pi by phi cos 2 pi theta by phi, right? So this is how you are having this ds by d theta, and as we all know, this d theta by dt is nothing but omega, right? So this is how you are having this ds by d theta and d theta by dt, right? So if you further simplify velocity, then it will be h omega upon phi 1 minus cos 2 pi theta upon phi, right? Because here this 2 pi will cancel out and h omega phi we are taking out. So this is how you will get velocity. Now again, at this theta is equal to phi by 2, you will have maximum velocity v max, that will be equal to 2h omega upon phi, because at theta is equal to phi by 2, cos 2 pi theta by phi will be cos pi, right? And cos pi is minus 1, so 1 minus minus 1 will be 2, so it will be 2h omega upon phi. So this is how you will have maximum velocity. So once you have maximum velocity, similarly you can go for maximum acceleration. See, acceleration is nothing but dv by dt, so it is again dv by d theta by dt, right? So here if you go for dv by d theta, then it will be h omega by phi 2 pi by phi sine 2 pi theta by phi, and again d theta by dt will be omega. So if you further simplify it, then it will be 2 pi h omega square upon phi square into sine 2 pi theta upon phi, right? So now here in case of this cycloidal motion at theta is equal to 5 by 4, you will have your maximum acceleration, right? Because at theta is equal to 5 by 4, you will have sine pi by 2, and that is 1. So that is why it will be 2 pi h omega square upon phi square. So this is how you are having this various types of cams, then various types of followers, then what are the basic terms in cam, then this different types of motion of follower, right? So once you have idea about all this, you can attempt some of the questions, right, from GATE previous year. So if you see this one, this is a GATE previous year question from GATE 2005. So what question says is, in a cam follower mechanism, the follower needs to rise through 20 mm during 60 degree of cam rotation. So this h is given as 20 mm, right, during the 60 degree of rotation of cam. The first 30 degree with constant acceleration, as we know 5 by 2 is there, right, in case of constant acceleration and deceleration. So this 5 by 2 is 30, right, the first 30 degree with a constant acceleration and then with a deceleration of the same magnitude. Now the initial and final speeds of the follower are 0. The cam rotates at a uniform speed of 300 rpm, right? So from which you can get omega, right? Omega is 2 pi m, right?
Sir, option B would be the answer, sir.
Okay, so all of you have got the answer, the maximum speed of follower that you need to calculate. Yeah. Please calculate, everyone, and tell me what answers you are getting. One of you are getting answer B. So please all of you calculate and let me know what is your answer. Type in the chat box your answers. You can attempt this question, right?
Yes, sir. Option B.
Okay. Option D somebody has written. Somebody has given option D.
या सर बी आ रहा है.
Okay. What about others? Hello.
Yes, sir.
So option D some of you are getting.
Yes, sir.
Here see, as we have seen, right, this V max in case of this constant acceleration and deceleration, it is 2h omega upon this phi, right? So in this 2h omega upon phi, you are given that h is equal to 20 mm. It means it is 0.02 meter, right? and omega you need to calculate, that is 2 pi n by 60. So what is n? N is 300, right? And so from this you can get omega is equal to 10 pi. So once you get this omega is equal to 10 pi, right, h is equal to 0.2 and phi is equal to 60. So you need to convert it into radian by this pi by 180. So then pi will be pi by 3. So if you put all these values in this 2h omega by 5, then 2 into 0.02 into omega is 10 pi and this phi is pi by 3. So now if you simplify this, what you are going to get is this pi will cancel out, 60 into 0.02, 6 into 0.2, that is 1.2 meter per second. Correct? Hello?
Yes, sir. Yes, sir. Yes, sir.
So this is how
Yes, sir.
you will have this in your this particular question. Let us go to the next question. This is from GATE 2008. So in a cam design, rise motion is given by a simple harmonic motion h by 2 1 minus cos pi theta by b, right, where h is the total rise, theta is the cam shaft angle, beta is the total angle of the rise interval. The jerk is given by. So can anyone tell what is jerk? We have discussed, right, just now.
Sir, third derivative.
Third derivative. So you need to calculate t cube s upon dt cube, right? That is jerk. So can you tell me the answer? Hello?
Sir, option D.
Okay, let me see what others are getting.
Yes, sir. Option D. Minus pi cube h by beta square 2 sine pi theta by beta.
All of you are getting the same?
Yes, sir. Yes, sir. Same.
Okay, so I am not going for it, right? All of you are getting this. So this is how you can get jerk in this particular question. So all of you have got this. Okay, so let us go to the next question.
सर जो ये जो होता है ये थीटा के रिस्पेक्ट में होना चाहिए या फिर टी के रिस्पेक्ट में होना चाहिए थर्ड डेरिवेटिव जर्क के लिए?
I guess in terms of t only.
पिछले वाले क्वेश्चन में तो थीटा के रिस्पेक्ट में होने से काम चल गया था.
Okay, but I guess as per Ratan it is d cube s upon dt cube. Still I will check, right? Okay.
Okay, sir. Okay, sir.
Okay, thank you. So here if you go to this next question, that is from GATE 2014 S3 session 3, right? So what this question says is, consider a rotating disc cam and a translating roller follower with zero offset. Which one of the following pitch curves parameterized by t lying in the interval 0 to 2 pi is associated with the maximum translation of the follower during one full rotation of the cam rotating about the center at xy0. So basically here x and y motion are parameterized with t, right? So t is a parameter according to which x and y motion is varying of a follower. So basically what you have to do is the maximum motion will be given by, let us say, d is under root x square plus y square. So as I have given you the hint You can try and tell me what is the answer of this particular question. Can you try this one?
Sir, option C.
Okay, let others calculate. So please type in your answer in chat box.
Sir, should we integrate this one?
Sorry?
Equal to root of x square plus y square.
So
We can explain that.
x square plus y square, let us see how see, you can try each of the given option, right? So if you go for
Like parametric equation, we have to follow the value of x and like x equal to sine t and cos t.
see, basically this t is a parameter according to which motion along x and y is varying of a follower, right? If this is a cam and there is a follower, right? So this follower is having motion in x and y according to this parameter t, right? So and the total motion will be the sum, or we can say resultant of it. That is why it is under root of x square plus y square. So if you go for a, then it is cos square plus
That would be
sin
1, sir,
square. Yeah,
for option A.
right. So for a it is 1, right? For b, if you go, then it is cos square t plus 4 sine square t. So it is actually 1
2.
plus this 3 sine square t. So now it will be maximum when that sine square t is 1. So that is 1 plus 3. So that is 2. Right? It is. Let me correctly write this. So it is 2. Now if you go for option C, that is d is equal to 1 half plus cos t square, that is 1 by 4 plus cos t plus cos square t, right, plus 4 sine square t. Now you will have this as this 1 by 4 plus cos square plus sine square is 1. So 1 by 4 plus 1 is 5 by 4 plus cos t plus 3 sine square t. Now this will be maximum when this will be maximum, right? Cos t plus 3 sin square t. So if we go for d by dt cos t plus 3 sin square t is equal to 0, then what you are going to get? You will get at t is
cost equal to 1 by 6.
yes, at t is equal to pi by 2 or 3 pi by 2, it will be maximum, right? That you are going to get from this particular equation, because cos t is minus sin t plus this 6 sin t, and sin t will be cos t, right, equals to 0. So from this you will find that it will be t equals to pi by 2 or 3 pi by 2. So when t is equal to pi by 2 and 3 pi by 2, you will get this t as 2.06, right? And if you go for the final one, that is d, so in case of d, it is again d is equal to square root of x square plus y square. So over there you will have this pi by 4 plus cos t only, because only sin t is there, so 3 sin square t will not be there in that case. So it will be only 5 by 4 plus cos t, and it will be maximum when cos t is 1, and when cos t is 1, it is 5 by 4 plus 1, so that is 9 by 4, so that is 1.5. So this is how you will have this maximum is at C, right? So this is how you can solve this kind of questions, right? Now if you go for
Sir,
yes,
sir, what is D?
t is that follower motion, right? As they have asked, what for what will be the means for which particular equation it will be maximum, right? D is this maximum translation of the follower.
So isn't that the duality of the follower?
Sorry.
D, a dual, like the dual portion in the graph we have seen D model.
No. Dual
Okay.
is at what what for what particular duration your follower will remain steady. That is dual.
Remain steady, yes, sir.
Dual means
Actually, I thought that D
no
means
no
the
no
duality of that
no.
follower.
The duration for which follower remains steady, right? Follower remains steady. So this is how you are having your this particular problem solution, right?
Sir, why are we actually exactly taking root over x square plus y square? Sir, like, is it with respect to origin or something?
Yes, because that will be the resultant of the distance traveled by follower. That is why we are taking this under root of x square plus y square. Okay.
Yes, sir. But in each and every case, we need to differentiate also.
See, each and every case we need not to differentiate, because see, for example, for this B option, you are getting 1 plus 3 sin square t. So it is obvious when sin square t is 1, at that point only you will get what we can say maximum value of D. So 1 plus 3 will be 4, and that is 2. Are you getting why we have not differentiated for this particular point?
Yes, sir.
And similarly for D also, it is obvious that then when cos t is equal to 1, at that point it will be maximum in case of that parametric equations. For C only you are having this both cos and sine. So when you have both, you don't know at what particular point it will be maximum. That is why you have differentiated and equated it to 0. Are you getting?
Yes, sir. It's like how much like the maximum distance which it can move from the origin.
Sorry?
Like, is it like how much distance the follower can move away from the origin? So maximum distance it can move.
Yes, so basically this question is saying that what are the parametric equations which will allow the maximum translation of followers. So if your follower is going to follow this equations, right, which is given in option A, that xt is going to vary according to cos t and yt is going to vary according to sin t, then the maximum follower travel will be 1, right. Similarly, if it,
Yes.
option B is going to be followed, then maximum translation will be this 2, right. When it is going to follow this C, at that point the travel is coming 2.06, right, and for option D it is coming 1.5. So basically, if follower is going to follow the equations given in the option A, then it can travel maximum by 1. Is it clear?
Yes.
Okay. So the next is this one. It is from GATE 2018 session 2. In a cam follower, the follower rises by h as the cam rotates by delta at constant angular velocity omega. The follower is uniformly accelerating during the first half of the rise period, and it is uniformly decelerating in the latter half of the rise period. Assuming that the magnitude of the acceleration and deceleration are same, the maximum velocity of the follower is, actually this we have calculated and used also. Can anyone tell?
So C option.
Yes, that is straightforward, right? It is 2h omega upon delta. So everyone is getting this right, or anyone is having any doubt? Hello,
No, no, sir, no, no.
right? So
सर एच बाय फाइव मतलब एच ओमेगा बाय डेल्टा होना चाहिए
sorry,
था सर एच ओमेगा बाय डेल्टा होना चाहिए था 2 क्यों
it is 2h omega by delta only.
सर ये मतलब कांस्टेंट वेलोसिटी वाला है ना
No, 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 no. It is uniformly acceleration and deceleration,
ओके सर ओके ठीक
right? Uniformly deceleration during the latter half, right? It is not constant velocity. Okay, okay, okay. So let us go to the next one. So here what we have asked in this GATE 2019 session 1, a flat-faced follower is driven using a circular eccentric cam rotating at a constant angular velocity omega at time t is equal to 0. The vertical position of the follower is y0 is equal to 0, and the system is in the configuration shown below, right. So here you are provided that offset follower is there, right, and what you need to do is you need to calculate this particular equation, how it is going to vary, right, the vertical position of the follower face, right, yt you have to calculate. So for that I have actually provided this hint over here, right. So you can use this hint in order to find this yt, right. So you can consider this as O pivoted point, right, then point on the flat face follower as B, right. So and this particular axis of what we can say that cam is given as P point, right. So from this you can actually see and try how you will get the equation for this displacement y. of the follower, right, as it is mentioned here, how it is going to vary according to the cam rotation, right. So that is what it is given in the options. You have to see how cam rotation angle is going to affect the follower travel, because this omega t is nothing but theta, right. So can you try and solve this one? From this hint you can try, I guess.
Sorry, sir, didn't get that.
See, how your what we can say follower is going to travel in that particular direction as mentioned here, right. Say here two different configuration is given, right. One is this OB and the other is OB dash, right. So your y is the direction, or what you can say is the distance traveled in this vertical direction, right. So if you see that if your follower is moving from OB dash to OB, right, then the distance traveled in that vertical direction will be OB dash minus OB, right, in this figure. So now I guess you can try.
Okay.
Hmm. Please mute yourself.
Okay, okay. Sorry, sir.
Mm-hmm.
So can you show the options?
Yeah, yeah.
B.
B.
B, sir.
Okay.
Yes,
Okay.
yes, sir.
What are the others getting as the answer?
Sorry, sorry, sir. C. E into 1 minus cos omega t. Sorry, sir. That would be C.
Okay, okay, okay. So what about others? What are you getting as the answer?
C, sir.
Sorry?
C.
C. Okay. So basically, as I have given you the hint that y is this OB dash minus OB, right? In the direction y, this will be the distance traveled. So OB dash is equal to Cm, as you can see from the figure. So y is nothing but this Cm minus OB, right. And as you know, this Cm is this PC minus Pm actually, right, that is Cm. You can see this PC minus this Cm, that will be the sorry, that PC minus Pm, sorry, PC minus Pm will give you Cm, right. So and what about OB? OB is what? OB is actually OB, what you can say that if you see this OB, then I guess OB can be given by this radius minus E, right. This is the radius R, right. So OB will be given by R minus E, right. And what is this PC? PC is again radius only. And what is PM? So PM is actually, if you see this triangle, right, this triangle, so this is your PM, right? This is P and this is M, this is E, right? And here you are having this theta. So PM is basically E cos theta. So R minus E cos theta, right? Minus R minus E. So if you simplify this, then what you will get, E minus E cos theta, that means E1 minus cos theta. Now theta is omega t, so E1 minus cos omega t, that will be your y. So that is the answer C, right? So everyone is getting the same. Hello.
Yes, sir.
Yeah.
Yes, sir.
Okay. So the next is from GATE 2020. Here a cam with a translating flat face follower is desired to have the follower motion y theta is equal to 4, 2 pi theta minus theta square when theta lies between 0 to pi. Context considerations dictate that the radius of curvature of the cam profile should not be less than 40 mm anywhere. The minimum permissible base circle radius is that you need to calculate. So basically you have to calculate this minimum permissible base circle radius, and what is what you can say condition is you need to check that radius of curvature. So if you remember how you can get radius of curvature from our discussion, then you can try it. Anyone remember radius of curvature from those derivatives?
Yes, sir.
Derivatives.
Yes, sir.
Okay, so you can try and type in your answer in the chat box.
Okay, sir.
So here see this y is given as this 4 2 pi theta minus theta square. So radius of curvature is actually this dy by d theta, right? Actually radius of curvature is that d square s by d sorry d square y upon d theta square, but this is the slope, right? Dy by d theta, as we have seen in the geometry of geometrical derivatives. So this dy by d theta will be 4 2 pi minus 2 theta. So this dy by d theta is nothing but 8 pi minus theta, right? Now here, in order to y become maximum, your this dy by d theta must be equal to 0. So if you do that, what you are going to get is the condition is theta is equal to pi, right? So as I have told you that the second derivative d square by d theta square is that curvature, that is a. So if you go for the d square y by d theta square, that is dv by d theta also, right? So v is this 8 pi minus theta. So your dv by d theta will be minus 8. Now in order to go for that minimum value of your base radius, what is given in this problem statement is your
Sir, sir,
yes
sorry for interrupting.
yeah.
How dv by d theta would be the minus 8? Because pi minus theta would be 0, sir.
See, no, this is for particular case. Pi minus theta is not 0. We have applied that condition dy by d theta is equal to 0, right, for maximum y. So theta is not
Okay,
equal
okay.
to pi everywhere for this v, which is dy by d theta, right? This is special case of theta is equal to pi for maximum y, right? But in general,
Yeah, okay, sir.
v is 8 into pi minus theta. Okay.
Okay, okay.
So if this v is equal to 8 pi minus theta, then dv by d theta is minus 8, right?
Mhm.
Now what is given is that base circle radius should not be less than 40. So that is minimum base circle radius is given as 40. So let us say that r base minimum is equal to r base plus this y plus a minimum, right? It is for this particular case, right? So in case of flat face follower, this is the geometric relation between this minimum base radius and this what we can say displacement and acceleration. So now if you have this equation with you, then what is going to happen is minimum is given to you as 40, which is required, right? So now
Sir,
yeah,
excuse me, sir.
yes.
So that is R cam minimum, no? Left hand side.
Oh yes, sorry. Thank you. So yeah, it is for cam profile, cam profile, right? So that minimum radius of curvature for the cam profile should not be less than 40 mm anywhere, right? Sorry. Yeah, so r cam minimum is equal to this r base plus this y plus a minimum. So in that case you need to calculate this minimum permissible, that base circle radius, right? So this is the geometric relation provided, that r cam minimum is equal to r base plus y plus a minimum. So this r cam minimum is given as 40, r base you have to calculate, and this you have already calculated this y and a, right? So as we have seen, this y is 0, right, and a we have calculated as minus 8, right? So here if you further simplify, then r base will be equal to 48. right? So here your answer will be this 48 mm. So this is how you can solve question on this cam, right? So is there anything else?
Sir, what is y plus a minimum?
Actually this particular relation is from the geometry of the flat faced follower, so we are not doing the derivation of this, right? So for now we will take this. Okay.
Okay, sir.
Okay, anything else? Hello.
No, no, sir.
Okay, so I guess this theory of
Excuse
machine.
me, sir.
Sorry.
So actually, in the last question, actually you told that like radius of curvature is calculated with second derivative with respect to theta.
Sorry, can you please repeat?
Actually, the calculation of radius of curvature,
Uh-huh.
like I thought you had told like we need to calculate by second derivative
Yes,
with
yes,
respect to
first.
theta.
Yes, first derivative is slope, right?
Yes, sir. But after that we followed some other steps, so I got confused.
So after that we have gone for the second derivative also, right? Here d square y upon d theta square, that is a, which is dv by d theta. Yes or no?
Yes, sir. But like if we directly do the second derivative, I was not able to find the answers. Can you kindly explain the solution again, sir, like briefly?
Yeah, so actually I didn't get, if you go for directly the second derivative, then what is the problem you are facing?
Sir, I think if I get the explanation briefly again for this answer, I can understand.
See here in case of this cam profile radius and base circle radius, you need to calculate the that minimum possible base circle radius. So if you go for the minimum of both cam profile and this phi plus a minimum, then you will be able to what we can say, calculate. See here this a is not simply the what we can say this acceleration, because in our that kinematic derivatives and this physical derivative, right? So in kinematic derivative, if you remember, the first derivative ds by d theta was representing the slope of the cam profile, right? While the second derivative d square s upon d theta square was simply giving the radius of curvature, right, of cam profile, right? So here what you are given is that minimum cam profile radius is given, right? So based on that you need to find the minimum permissible base radius. So with minimum cam profile radius and this y plus a also be minimum, so here y is displacement of follower, right? So we are considering that displacement of follower is 0, right? And a is the radius of curvature, so which we have calculated from the second derivative as minus 8, right? So this will be minimum when we consider that follower displacement as 0 and the radius of curvature as this minus a. So once you consider this, then your minimum possible base radius will be whatever minimum cam profile radius plus this whatever we have calculated, because this a is come this negative 8. So that is why this minimum base radius is 48. Are you able to get it?
Yes, sir. Actually, after finding this like a radius of curvature, you're substituting in this particular equation. Sir.
Yes, yes. After finding this radius of curvature, we are substituting it in this equation.
Yes, got it.
Okay.